So you can see similar experiments, but in this one, 2 groups were selected for handicap, another group for treatment A and another group for treatment B. So we want to test hypothesis for if treatment B is better than treatment, treatment A, must type A here. Treatment A is better than, let me type. Okay, sorry, treatment A, okay, like this. So if treatment A is better than treatment B at 0.05, and then assess the possibility of calculating the effect size, and then something like that. The same, and this one is just the difference. So this 2-tailed and this is 1-tailed. So you data analysis, like always, so you click on data analysis, and then here we change. We don't use the paired sample, but you use the 2 samples assuming equal variance. So we always assume equal variance because we randomize, we select a group under random, using random selection. So I encourage you to use equal variances instead of unequal variance, but if you read further, you can test for that as well. So click on OK. And then let me move this. So this is treatment A. We select, what is the question? If A is better than B. So A, so you can play around. It, like what I say, it doesn't matter much which one you select first, but you can check on the mean score for that. But what matters is the difference. Is it significant, or the betterness? Is it different? And then I say get 0. We don't have to change anything, and then we included labels. And then it's 0.05, and then click on OK. And then, like what I said, you can just move it. So you see that there's pooled variance here. If you read our other slides, and then even in the manual calculations, we use pooled variance. So to eliminate bias, because sometimes the number of participants in a study, the number is different. Sometimes the variance is different, so it's combined together. So there is a formula for that if you do it manually. So you see that there is pooled variance here. And then you can see just from the mean that treatment B is better, depending on the mean, than treatment A, but is that difference significant? That's what matters. Okay, I forgot to round off to 2 decimal places, just a highlight and right click, format cells. Number, so Excel already, I don't know, this Bill Gates already did 2 decimal. I don't know why they like 2 decimal places. I was watching actually how they created these things. Is it on Netflix or something? These guys are crazy. So this is a 1-tail, and I don't want to be as crazy as them. So delete, because it's 1-tailed, and then you see that this is 0.01, and then we are testing at 0.05, meaning that there is a significant the increase. What's the question again? Yes, is significantly better than treatments, meaning that treatment A is significantly better than treatment. No, so I want to write treatment B here. So treatment B is better than treatment B is better than treatment A. Let me correct it for you again. Treatment B is better than treatment A. Okay. Where is our, okay, so it means that treatment B is better than treatment A, of which you can see the mean is 7, the mean for this one is 4.8. Yes, it is better, we understand that, but is that difference significant? Yes, we say it's significant, because in the manual calculation says that the T obtained is in the critical region. That's what it means. Okay, it's one directional. So like what I said also, this negative 2.5 doesn't matter. If we had selected B first and A, so let's say B is this side and A is this side, this is going to be a positive. So it's not like a big deal, but you have to be technical around it. You have to report like if you look at the mean. So that's what you do. If there is significance, you proceed to calculate also the the effect size of which you use variance, this variance. So square root of this is standard at the denominator of the equation, and then the mean difference is on the numerator. So it means that I think 7 minus 4.80 divided by the square root of 3.76. So the answer that you obtain, you can interpret like, is it a small effect, is it medium, or is it a large effect? Okay, only that. If the question is asking also to calculate the variance, you can also do the same like what I did. You can use eta squared, the t squared divided by t squared plus the degrees of freedom, and then it'll be sorted. Let us move quickly to that smoking experiment, whereby we want to just assess the difference. So this is a two-directional, it's two-tailed, it's non-directional, sorry. So it's a two-tailed test. You also do the same as the term. In this one, doesn't matter which ones you start with, like what I was trying to explain, the negative and the positive value of the t. So we assume equal variance as well, and then we click on OK. And then we want to select the first one, procedure A. We'll move down, and then the second one, that's procedure B. So I use the same scores for independent, dependent teachers so that you can see the difference. And then this 0.01, don't forget to do that. And then you click on OK. So what is the difference? That the degrees of freedom is different, and there's sometimes the put variance can change things, and then the way that you do your calculation. Okay, let me round up to decimal places. And I think after watching this video, you will be okay. You'll be sorted. If you get it wrong, it's not, yeah. I almost say it's not my fault. Yeah, that's not for the children. Okay, and then I delete. I'm deleting the one tail because the question is a two-tailed. How is it? Okay, delete. So you see this is more than 0.01. So there is no significant difference between procedure A and procedure B. That's that. If it's like that, you don't proceed to calculate the effect size. But if there is a significant difference, you automatically proceed to calculate, because the aim of the experiment is to assess the effect, let's say, of doing something, the effect of intervention, not only the difference, but the effect of that. So that's that only. You can see even the difference. This is a small difference. And then you can check also the degrees of freedom is 18 on the dependent t-test. It was 9, because this one is n minus 1 plus n minus 1, or other textbooks they say n minus 2 if the sample size are equal. Thank you so much. Enjoy. So don't forget to follow the steps like what I did in another video. So the first step, you step the hypothesis, and then second, the critical region, and then the third, that is what I'm showing you, the computation. And then the final stage is whereby you make a conclusion, be as specific and clear as possible, so that whoever is assessing assessment can see your answers. You mustn't try to look for them. And then, like what I said, you can copy and paste this into a Word document and other things. Thank you so much for watching. I hope I didn't take much of your time. Thank you.